Hello students. So in our last session we have discussed about the data products. Data products, how we can obtain, what are the qualities of data product, how we can use the data and what analysis can be done. We have already discussed that things. There are various numbers of sensors. All sensors are made accordingly that we can extract different types of information of earth surface of any earth feature. So accordingly, we are designing our sensors and accordingly we are ordering the data. Now, I would like to recall all the topics of fundamentals of remote sensing which we have discussed in whole unit, in whole module. Okay, students. So now I would like to draw your attention again towards starting from what is remote sensing to the important topics which are covered in this module. Right, student? So here you can see, first of all, we have discussed technically and in day-to-day life what is remote sensing. So with a quick revision, we will do that. In day-to-day life, remote sensing is like rays which we can see, which we can measure, but we cannot touch that, and we get accurate information about that object. That is known as remote sensing. In day-to-day life, our eye acts as a remote sensing process. Moving further, technically we go, what does it means? The science of acquiring information about the earth using instruments which are remote to the earth's surface, means which are not coming into the contact of earth even though we get the information about the earth, right? That is known as remote sensing. Next, moving further, technically if we see remote sensing, which type of rays comes from the remote sensing to take the data? That is known as electromagnetic radiation, right? So electromagnetic radiations are coming from the source of energy, and then they are taking the information about the earth feature. Now how is sensing done? By recording, reflecting of rays or emitting the rays. These three processes are used to analyze the information, right? Next, we moving further. What is the in Indian remote sensing launching process? You all know that we are making the sensors. Sensors are sent into the vehicles. Which two types of vehicles India has right now? That is PSLV and GSLV. Again, what is PSLV? Polar Launching Vehicle. And what is GSLV? GSLV is Geosynchronized Launching Vehicle, right? That is GSLV and PSLV. Now moving further, we get to know that the history of remote sensing, how it started, and ultimately we have started preparing the sensors as per the requirement, what information we want to extract, we are using that type of sensors, right? Next, moving further, the technical terminology. I repeat here again, even during the session, I have said that technical terminologies are important. That is orbit, types of orbit, geosynchronized orbit, polar orbit, satellite, sensor, SWAT, and Nadir. Right? Geosynchronized orbit, polar synchronized orbit, how it works? You have to just remember, if it is geosynchronized orbit, it will be taking data according to the latitude manner, and if it is polar synchronized, it will be taken in the longitude manner, from north to south, south to north, north to pole, north pole to south pole, south pole to north pole. Now moving further, satellite, that is artificial object that is placed in orbit. SWAT, the area image on the surface, is referred to as SWAT, which is already clearly shown in the figure. Orbit means what? A particular path on which repeatedly the object travels. Now moving further, again, you know what is platform. Platform is very important terminology as through which we are taking the information. Now if there are three types of platform, which are the three types of platform? There is ground based, airborne based, and spaceborne based. So these three types of platform are actually used to gather the data, which has its limits. If it is ground based, there is up to 50 meters they will be taking the data. If it is airborne, it will be taking 50 kilometers, right? And spaceborne, we all know that 100 kilometers to 36,000 kilometers. So you have to remember the range and you have to remember which type of platforms are there. Now this is a picturing. I am showing how satellite captures the data. Yes, we all know that through the sun. Now right now here in this picture, sun is acting as a source of energy that is emitting radiation that is going to the target is again emitting some type of radiation that is going where the sensor is capturing, and through sensor, you know, we have a ground stations kept here, and in ground stations the data is recorded. Where is the ground station in India? It is located in the Shadnagar. Next, moving further, what is EMR? Yeah, this is an important topic we already have discussed. That is, EMR is electromagnetic radiation. Electromagnetic radiation has two types of properties. Every object has two types of property. There is magnetic rays and electric rays, right? Through that they emit some or the other kind of energy, and that energy are stored in different ranges, that is electromagnetic spectrum and electromagnetic radiation wavelength. There are short waves, there are long waves, there are microwave rays, there are thermal infrared rays, visible rays, UV rays, various types of rays. According to it, we are designing which type of rays are used, visible range, and we are converting our image into visible, and then we are analyzing our image. Moving further, there are the characteristics, means the remarks which I have shown here in the table, that is the gamma rays, X-rays, visible, infrared, microwave and radio. Now here I want to recall the point of long wavelength and short wavelength. Waves who have long wavelength will be having what? Low frequency, low energy. Waves who have short wavelength having high frequency, high energy. Right? I here in the figure I have shown which are the radio waves, microwaves, infrared, visible. You have to see. Now, important point here in this slide, I would like to tell that two characteristics are very important to understand the concept of remote sensing in EMR, that is wavelength and frequency. Moving further, this is very important topic, that is component of remote sensing. Yes, there are 7 main components of remote sensing. Here I would like to recall the energy source and illumination, that is radiation in atmosphere, interaction with target, recording of energy by sensors, transmission, reception and processing, interpretation, analysis and application. Process by process, this sequence should be maintained. First we have energy source, that is the alphabet A in a figure. You can see that there is a sun is sending some energy to the target. During the target at B, it will interact with the atmosphere, and after interacting with atmosphere it goes to the target, and after going to the target again it goes where you see at alphabet D, that is our sensor will record the information about that object, and then it is transmitted to the ground station, and then from ground station we are processing it, we are taking decisions, and we are giving some important information. So this is how the component of remote sensing acting. And yes, principle of remote sensing is also the same process. Now, which type of sensors we are making in day-to-day life for collecting the data? That is active sensors and passive sensors. Yes, student, here I again repeat, you get confused between what is active sensors and passive sensors. What is active sensor and passive sensor? One sensor requires sun, which is known as passive sensor, and one which does not require sun, it can take image by its own self pulses, that is known as active remote sensing, right? So active and passive are important, and hence we are making the sensors according to active and passive. Next, passive. Yes, sun is the most powerful source of energy. Sun is the main source of energy in passive. When sun is present only, then only passive sensors can take the images. Next, moving further, you can see, now this is very important, how energy is interacted with atmosphere. Yes, when radiations are coming from sun or radiations are coming from sensors, they have some or the other interaction with whom? Atmosphere. Because from space, they are coming to the atmosphere, and then atmosphere to the target, and again they are going back to the atmosphere, and again they are stored in the sensor. Right? So there are 4 type of process, which is the process, that is scattering, absorption, reflection, and refraction. So this type of process takes place when the energy interact with atmosphere. So scattering means what? It will scatter around. There are 4 main types, but we are readily here doing 3 types of scattering, that is relay scattering, mean scattering, and non-selective scattering. Scattering, when particle or large gas molecules in atmosphere interact, causes the electromagnetic radiation to redirect from its original path. It will be redirected from its original path. Relay scattering occurs when particles are very small compared to the wavelength of radiation. Mu scattering occurs when particle and size are both are same. So similarly, non-selective occurs when particles are same as the size of wavelength itself. Next, moving further, diffraction, reflection, and absorption. Many types of energies and radiations are absorbed. That absorbed radiations are ozone, carbon dioxide, and water vapor. There are 3 forms that absorb energy. Diffraction means what? When the EM radiation travels from one medium to another medium, they have what? They have different refractive index, and that is why radiation might get diffracted. Reflection is there is diffuse reflection and specular reflection. That depends on what? The surface of the energy where it is heated. Next, moving further, energy interaction with the surface features. Yes, it is very important. Firstly, what happens with the energy that heats the earth's surface, that is absorbed and not scattered, will be stored in the sensor, and that sensor will give us some or the other way information. So here the three fundamental processes takes place. Which are the three fundamental? Absorption, reflection and transmission. You should remember the figure into the figure shown here. That is, if I say a leaf figure, that is the incident ray are coming, some are absorbed, some are transmitted and some are reflected, right? Proportion of each will depend on whom? The wavelength, the angle of incidence and the surface of material and condition of the feature. Moving further, which is the most important characteristics to be studied? That is the energy interaction with earth surface. That is the reflection of surface occurs in two ways, that is specular reflection and diffuse reflection. What happens in this? In specular reflection and diffuse reflection, specular means there is a giving a mirror image, means there is a smooth surface. In diffuse there is a, what happens, there is a rough surface, and angle of incidence is not equal to angle of reflection. Moving further, data acquisition and recording. Yes, in detail, very well we have understood this. Data acquisition and recording, there are panchromatic and multispectral data. However, we want to capture the data, we are making the sensor. Which was the first sensor? The first sensor was Aryabhatta. And then we have started the series of which sensors? That is Indian remote sensing sensor. That is 1A, 1B, 1C, 1D and so on. Now moving further, how is data recorded? Data is recorded in the pixel form. Pixel has what? That has intensity and location address. What is the intensity here? I have discussed here, we have range from 0 to 255. Accordingly, we are selecting the colors and the pictures are showing us the different varieties of pixel, that how much value it has. What is the intensity of that pixel is, right? Next, moving further, which are the various types of remote sensing? Specifications already have discussed. You have to just remember that IRS 1A, which sensors were there in IRS 1A, right? What is 1C sensors? So which type of sensors are there? What is the resolutions? So this is how we have done. The Soral resource at 1, Kalpana. Data is identified on the basis of feature extracted. How is data identified? With the help of its signature itself. With the help of signature, we can identify the data. Moving further, image resolution, spatial, spectral, temporal, and radiometric, all are discussed in detail. Spatial means location based, spectral means number of color bands, temporal means every season we can take the data, and radiometric means color depth data. We will discuss this also in further, because these are the important characteristics that you have to remember, that how is the resolutions of the image. Next, looking to the image, you can recall that what are the image and how is the resolution, and accordingly we can see that what type of resolution is good. Next, moving further, for false color composite, for what we are using it, that our eye can rectify all the features that is taken in satellite image. Now various data format, yes, we have already discussed in detail. Okay, so these are the data format is, that is NRSA, Bhuvan, ISRO and USGS is providing us what? The data which we want to analyze and which we want to do the research, or which we want to make any model or the solution for us, right? So there are various types of data available, and data available, they are based on level of processing, they are based on what? Output, media and scale and area of convergence, right? So standard products, value-added products and derived products, all the products are available on the website of NRSC, USGS, depending on the sensors and satellite that is been bifurcated, and hence we can obtain all the Indian remote sensing data are available on NRSC, that is National Remote Sensing Center. There is a center who is gathering all the information, all the satellite data, and through that we can do the analysis if as and required. We have to take the perfect latitude longitude position, and we can order the data and we can analyze the data, and we can do the decision making, model and problem solution. Output based media, that is photographic media and digital media. Area of coverage is full scene, specific band, geocoded, full pass, quadrant, map, sheet based, etc. All has different characteristics. All sensors have different characteristics. So sensors and the characteristics should be studied, and accordingly we can do the analysis of all the data. So here almost all the fundamental process of is over. You can see, yes, you can here see the last image. I would like to again recall it. The concept of false color composite, here I have shown it the last. You can see the color is changing of it. There is a temporal color every time it is changing, and at the end they have provided what? False color composite resolution. So according to false color, my eyes can identify that what is going on. Now you can see here the black surface, which you can see that we can identify that is water itself going, because the signature of it, you can see it is a river type formation going on. So this is how an image can be classified, and this is how it will helpful us to identify the features. It will helpful us for making any decision support system and any solution. Thank you for your attention, and hope you have understand all the parameters of fundamental of remote sensing.